Today's lecture is from section P1, and this is on equations involving radicals. Okay, so I first want to just look at the steps to solve these radical equations, and then we'll kind of do an example side by side. Okay, so the step one is to essentially isolate the radicals. So I'm going to do a little side problem over here so we can kind of walk through this. So I have the square root of 3x is equal to 12. Okay, so this is an equation involving a radical. So since this is the square root of 3x equals 12, it's a radical equation. So we want to solve this. So step one in solving this is to basically isolate the square root, or the radical. Now, we don't really need to do that in this case because it's given to us already isolated. So in this particular case, we don't really have to do any additional work. But if the square root were not alone on one side, then we would want to get it alone. Okay, so the second thing that we want to do to solve this is to basically raise both sides of the equation to the appropriate power to undo the root. So we're going to raise both sides to the appropriate power. So this particular example is the square root, which is implied because there's no number here. If it's a root other than 2, for instance, if I had something that looked like this as my root, then that would be an indicator that that's a cube root. Okay, so since it's implied, if there's nothing written here, we are going to assume that it's a square root. And to undo a square root, we square both sides. So that is what we're going to do. We're going to square both sides. If I were undoing the cube root, I would cube both sides, raise it to the third power. All right, so on the left-hand side, once I square something that's under the radical, the square root, I end up with just that back. So I end up with 3x on the left-hand side, and then 12 squared on the right is 144. So I have that. I want to essentially solve for my variable now. So I just need to isolate my x. Right? This is just like a normal, simple sort of linear type of equation in one variable. I just need to divide both sides by 3 here, and I end up with x is equal to 48. Now, just like absolute value, the act of squaring and raising things to powers actually sometimes can transform our equations into something that gives us solutions that aren't really valid. And so our last thing that we need to do is to check our solutions. Because just like absolute value, radical equations also can routinely produce extraneous solutions. Check for extraneous, meaning that they look like I solve the equation and I get the appropriate answer, but then when I go to plug it back in, it doesn't actually work. Now in our particular case, our initial maiden voyage into solving radicals, it does work. If I take the square root of 3 times 48, that's the x value, this does in fact equal 12 because this is the square root of 144, and that is in fact 12. So this does check out. So this one is good. So we can move on to a slightly more interesting example. We're going to go through these same exact steps again. So let's look at, we'll call this example A. Example B here is the square root of 2x plus 7 minus x is equal to 2. Okay, so step 1 says to isolate the radical. This is a really important step because if I try to square both sides the way that it is right now, because I have this minus x included with the square root of this, then what I'm really going to get if I do that is basically the square root of 2x plus 7 minus x times the square root of 2x plus 7 minus x. If I square it as it is, if I took and I put the 2 here, really that would be an indication that I was doing this. And this is going to have, while my radical will square itself away in the beginning, it's going to have these really ugly middle terms that come from here and here, and I don't want that. So I want to move the x to the other side of the equation. So I'm going to add x here and add x here. So I end up with the square root of 2x plus 7 is equal to 2 plus x. I could have written x plus 2, it doesn't really matter. All right, so now I'm ready to move on to step 2. I've isolated my radical, so I can raise both sides to the appropriate power. Again, I'm dealing with the square root. So to undo a square root, I square both sides. All right, so on the left-hand side, when I square something that's under the radical, right, I end up just getting this back. Over here, I think that I want to write this out twice. I want you to be very careful. This exponent here means that I have 2 plus x times 2 plus x. So I don't want to think that this is, excuse me, 4 plus x squared, because there is in fact a middle term when I multiply my two binomials together. So I have 2x plus 7 on the left, and then I'm going to multiply out my binomial. I have 2 times 2, which is 4. My outer term is 2x. My inner term here, right, is 2x. And then my last term's x times x is x squared. All right, so I have a little bit of simplification that I can do here. Rewrite the left-hand side, and then this ends up being 4 plus 4x plus x squared when I add the 2x's together. All right, so now you see how important it is to recognize all those different equations we've been talking about. Suddenly, I magically have a quadratic equation. And so the way that I always try to solve the quadratic first is to see if I can factor it. And that involves moving everything to one side and combining like terms and then setting it equal to 0. All right, so first I'm going to just rewrite this side so that I like it better when it's in this particular order. All right, I'm allowed to do that because I'm just adding. So I just have rearranged. I put the x squared in the front because when we factor quadratics, that's always where it is. All right, so I want to turn this side into 0. I really try not to have a leading coefficient that's negative when I'm going to factor, because that makes it a lot more complicated for me. So I'm going to leave it on this side. I'm going to subtract 2x from both sides. This gives me 7 is equal to x squared plus 2x plus 4. And now I can subtract 7 from both sides to give me my appropriate 0 that I wanted here. So I have 0 is equal to x squared plus 2x minus 3. All right, so lucky me, this is a factorable quadratic. Right, so I can factor this. I have x plus, and this last minus, the sign in front of the 3 is negative, so that indicates to me that I have a plus minus situation. To get positive 2 in the middle, right, I can only make 3 as 1 times 3. So that means that 3 is going to have to be in front of the plus because I want plus 3 minus 1 because that'll give me the positive 2. So then this gives me, right, I have the quadratic, so that means I take each one of these factored pieces and set it equal to 0. So I have x plus 3 is equal to 0, which gives me x equals negative 3. And I have x minus 1 is equal to 0, which gives me x equals 1. Okay. So this particular radical equation looks like it gives me an x equals negative 3 and an x equals 1 solution. And so I want to, because I know that radical equations sometimes gives me extraneous solutions, meaning that they're not really solutions, I need to check and make sure that that is the case. So let's try the 1 first. So when x is 1, then I'm going to put it back into my original equation, which is right here. Okay, I'm going to plug in 1 for x. That's going to give me underneath my radical here 2 times 1, which is 2, right? 2 times 1, which is 2, plus 7, which is 9. So I have the square root of 9, and then I have minus my x, which is 1, is equal to 2. And so the square root of 9 is 3, minus 1, which is 2, and that means that my x equals 1 is a solution. Okay, so let me move to another page here. All right. So now I want to check if when x is negative 3. Okay, again, I'm going to put this into this particular equation here, right? That's my original. I'm checking, does my solution x equals negative 3 work? Right, so I'm going to have the square root of 2 times negative 3 is negative 6 plus 1, So this gives me the square root of 1 here. And then I have minus negative 3 is my x equals 2. So the square root of 1 is 1. And then minus negative 3 really becomes plus 3. And I can see this is not going to work for me because I get 4 is equal to 2, which doesn't work. So x equals negative 3 is our first extraneous solution, so we throw it out. So the only solution to this particular radical equation is the original x equals 1 that I checked first. Right. So, all right, let's look at, we haven't done a cube root problem yet, so let's look at one of those. This is also considered a radical equation. So I have the cube root of x plus 2 is equal to 3, and I use the same steps, which is first isolate the radical, and I already have my radical isolated, so I am okay there. And then I'm going to raise both sides to the appropriate power. So this time I don't have, right, if there was no number here, I would assume it's 2. But since I have the cube root there, that means that I need to raise both sides of my equation to the third power. So when I raise this to the third power, again, just like if I took something, the square root of something, and squared it, I would just get what's underneath the radical. And by taking this time I have to cube it to get it out. So I have x plus 2 is equal to 3 cubed, which is 3 times 3 times 3, which is 3 times 3 is 9 times 3 is 27. All right, and so then my last step is to just solve for x. So I'm going to subtract 2 from both sides, and I get x equals 25. A quick check of this tells me that I have an appropriate solution. So I have the cube root of putting x back in. I get 25, or actually plus 2, right? And I'm hoping that this is equal to 3. And since this is the cube root of 27, and since 27 is 3 times 3 times 3, then the cube root of that is in fact 3. This checks out. So x equals 25 is an appropriate solution. All right, so these are how we solve radical equations. Now something else, right? Sometimes our radical equations are sort of in a different form. And a lot of times we see them, they look a little bit different. And so we're going to talk about rational exponents. So a rational exponent is another way usually that we write the different types of roots. And they are written as, it's rational means that it should be written as a fraction, sort of a, so the way that our fraction works is we have the power over the root. Okay, so that original equation that I solved, the square root of 3x is equal to 12, right? Another way that we could have written it is 3x to a rational power. Okay, so the power, right, there is no power. We can assume that if it's not written, that's like to the first power. So the power in this case, since there isn't one written, we're going to assume it's 1 over the root. So again, it's not written, and when it's not written, we assume that it's a square root, and we use 2 for that. So I could have written this as 3x to the 1/2 power is equal to 12. So this is an alternative to writing the square root of 3x. So the previous problem that I just have up here could also have been written as x plus 2 to the power. Again, there is no power underneath the radical. If there was, it would look like this, right? Maybe I have something that looks like this. That would indicate that there would be a number other than 1 in my numerator. But since there isn't in my original, I'm going to assume that it's 1 because it's not written. And my 3 here for my cube root, that is my root. So this would be x plus 2 to the 1/3 is equal to 3. Excuse me. And that is rational powers.